objective of this today's lesson is that you will be able to identify arithmetic and geometric sequence. You'll be able to calculate the terms in arithmetic and geometric sequence. You'll be able to calculate the sum of terms in arithmetic and geometric sequence. You'll be able to calculate the sum to infinity of an geometric progression. Okay, so this is what we're going to do today. Yeah? Okay, so the first thing we're going to do is we're going to look at some of these terms. Okay, so I put here 6 terms here. So we have sequence, series, what is terms, sums, finite series, and infinite series. Okay, so let's look at the first one. What do we mean by sequence? Okay, a sequence is a succession or a list of terms like this. Sequence, we have T1, T2, T3, T4, and so on. When we want to show that the sequence is continuing, we put 3 dots after the comma. Okay, and we only need to put 3 dots. This is fixed notation. Okay, so a sequence is a succession or a list of terms arranged according to a rule. Okay, so this is an example of a sequence, or this is also an example of a sequence. Okay, it is arranged according to the rule. Maybe the rule here is 1 more, 2, 3, and then 1 more 4, 1 more is 5, 1 more is 6. Okay, a series, sometimes people use sequence and series interchangeably. Actually, they mean 2 different things. Okay, so a series is the sum of the terms of a sequence. So a series will be T1 plus T2 plus T3 plus T4 and so on. So when you have an addition symbol here, it becomes a series. So a series for the sequence above will look like this: 2 plus 3 plus 4 plus 5 plus 6 and so on. Okay, so that is the difference between a sequence and a series. Terms, each number in the sequence is known as a term. So this, we have term 1, term 2, term 3, term 4, term 5, and so on. Okay, so that is terms. Sum is when you add together all the terms, you have the sum. Okay, okay, finite series. What do we mean by finite series? A series is finite if it stops after a finite number of terms. Say if our series is like this: 2 plus 4 plus 6 plus 8 plus 10. So we have 5 terms here. Okay, T1, T2, T3, T4, T5. So this series has stopped. There's no dots at the back. Okay, this series has stopped after 5 terms. Therefore, this series is a finite series. Okay, for infinite series, a series is infinite if it continues indefinitely. Okay, so if we have like this: 2 plus 4 plus 6 plus 8 plus 10, and it continues indefinitely, then this series is known as an infinite series. Okay, sometimes we can represent series or sequence like this. We can use a symbol. This symbol is known as sigma. Say we write here sigma 3n plus 4, n is equals to 1 until 3. This means, how do we read this, is the sum of terms in the sequence 3n plus 4 with n going from 1 to 3. Okay, so if I give you this symbol here, what is the first term in this series? What is the first term in the series?
7.
Yes, it's 7. And what's the second term in this series?
10.
10. Third term?
13.
13. How many terms are there in this series?
3 terms.
Three terms only, yes. Because we already fixed here already three. Yeah? So there are only three terms in this series. How much is this? 10, 20, 30. So we can write this is equals to 30. Okay. So this means this is a finite series with three terms and the nth term is obtained using this formula. If it's an infinite series, we can write it like this, okay? This is called sigma, n is equals to 1 up to infinity, say it's the same formula, okay? So this is for infinite series, we can represent it like this. For finite series, it's like this, okay? So far you can understand everything?
Madam,
Yeah?
or the finite series, the three have dash under it. Or memang ada dash bawah dia. Bawah nombor 3 dekat simbol.
Gimana tu? Tak ada,
Dekat simbol
no
side.
dash.
Oh,
No
okay.
dash, huh? No
Alright.
dash, huh? I just wanted to highlight it to you just now, okay?
Oh, okay. Okay, thank you, madam.
Okay, so we continue. So we finish with just the terms. Okay, so now we're going to go into arithmetic sequence, arithmetic progression first. Okay, arithmetic progressions. In arithmetic progression, the terms have a common difference. Say if you have an arithmetic progression like this, the terms have a common difference. That means, say if you have T1, T2, T3, T4, T5, and so on. Okay, so the terms have a common difference, which means T2 minus T1 is equals to D. T3 minus T2 is equals to D. T4 minus T3 is equals to D. Okay, so the terms have a common difference. This is the difference. Okay, so the difference here is D, the difference here is D, difference here is D. Okay, so look at the terms up here. Look at this sequence up here. We have 3, 6, 9, 12, and 15. What is D here? What is the difference here?
3.
3. And how do you get D is 3? Term 2 minus term 1 is 6 minus 3 is 3. Or term 4 minus term 3 is 12 minus 9 is equals to 3. So we know that D here is 3. How about the second sequence? Second sequence, what is the D? Term 2 minus term 1. Term 2 minus term 1 is 9 minus 11 is
2. 9 minus 11.
minus 11 is
Negative 2.
Negative 2.
negative 2. Yes, 7 minus 9, negative 2. 5 minus 7, negative 2. So the common difference is negative 2. The third sequence, negative 8 minus negative 5. How much? Negative 8 minus negative 3. How much is that?
Negative 5.
Correct. So negative 5. So the common difference is negative 5. So by right, you must check every single thing. Okay. So here, the last sequence, what is the D? How do you find that?
3.
Find the difference. Second term minus first term. 7 over 2 minus 1 over 2.
6 over 2.
6 over
6
2.
over 2 equals
6 over
to
2 is 3.
3.
11 over 2 minus 7 over 2 is 4 over, correct? 4 over 2 is 2. Correct? So here the difference is different. Okay. So therefore this is, we have no common difference here. So this is not a arithmetic sequence. Am I right? 7 over
yeah.
2 minus 1 over 2, 6 over 2 is 3. 11 over 2 minus 7 over 2 is 4 over 2 is 2. Okay. So this is not an arithmetic sequence. All these are arithmetic sequences. Okay. Okay, that's about the common difference. Huh? Okay. Okay. Say if you are given that the sequence is A plus D, A plus 2D, A plus 3D, and so on. Okay. From here, we know that the term 1 is A, right? First term
Yes.
is A. Okay. The first term is A, which also can be written as A plus 1 minus 1D, correct? 1 minus 1 is 0. 0 times D is 0. So it's still A. Term 2 can also be written as is 2 right here. So it is A plus, term 2 is A plus D, which can also be written as A plus 2 minus 1D. Term 3 is A plus 2D, okay, which can also be written as A plus 3 minus 1D. Term 4 is A plus 3D, which can also be written as A plus 4 minus 1D. So, what is our term N?
A
A
plus
A
plus,
plus N
N minus
minus
1D.
1D.
yes, A plus N minus 1D, okay? So, this is our formula to find the nth term in the arithmetic progression, okay? Where A is the first term, N is number of terms, N is number of terms, D is the common difference, okay? This is the common difference, okay? And Tn is the nth term, okay? So this is our formula to find the nth term, okay? Can?
Yes, madam.
Okay. Okay, let's go to the next slide. Okay, so we already know how to find the nth term, okay? So now we want to find the sum of the first n terms, okay? We want to find sum of first n terms, okay? So how do we find the sum of first n terms? We use the notation as n, okay? As n means the sum of the first n terms, okay? So just now we had the series A plus D, A plus 2D, A plus 3D, and so on, okay? So our Sn will be A plus D, plus A plus 2D, and so on, right? What is the last term here? A plus,
ND minus 1D.
yes, n minus 1D. What is the term right before this? Right before the last term. If this is A plus n minus 1D, what is the term just before this? A plus,
minus
N minus 2D.
yes, n minus 2D, okay? So we have this. So this is our first equation, okay? So if we rewrite this equation, okay, we're just rewriting this, bringing the back to the front. So we have A plus n minus 1D plus A plus n minus 2D plus until we have A plus D plus A. This is the same thing. We have just reversed it. We've written the last term first until the first term. Okay. Now we are going to add equation 1 and equation 2. So when we add equation 1 and 2, this plus this will give us Sn plus Sn is 2Sn. Okay. So this plus this, the first two terms we're adding is going to give us what? This is 2a plus n minus 1d. So each time you add all this, you get 2a plus n minus 1d. Okay, 2a plus n minus 1d. Okay, until the last term. Okay, the last term is also 2a plus n minus 1d. Okay, how many times do we add this? We add this n times. Okay, are you okay with this? We have just
Okay.
reversed it and then we add the first two terms. Every time you add the first two terms, you get this. Second two terms, you get this. Third two terms, you get the same things. Okay, so from here we know that 2Sn is actually n times 2a plus n minus 1 d. Okay, therefore Sn is equal to n over 2 times 2a plus n minus 1 d. Okay, so this is the formula to find the sum of the n terms. Or there's another formula that we can use. It is Sn is equals to n over 2a plus l. Okay, where a is the first term and L is the last term. So you can use any of these formulas, these two formulas here, to find the sum of terms in an arithmetic progression. Okay? Okay, this is just revision. You have done all this already. Okay, we're going to look at an example. Okay, example 1. Okay, given the arithmetic sequence, you're given 2, 10, 18, and so on. Find the 10th term. We're finding 10th term. So what are we finding here? T10. We want to find T10. Well, what is our Tn? What is the formula for Tn? Tn is,
A.
A plus n minus 1d.
okay, do we know our A?
Yes.
Yes.
Do we know what is D?
Yes.
Okay,
No.
what is our A? A is equals to
2.
2.
2. D is equals to,
D2
8.
minus 2. 10
correct?
minus 2. 8.
10 minus 2 is 8, okay? So do we know N?
Yeah. Yes.
N is
10.
10.
10, yes. So therefore, we are looking for T10. T10 is equals to 2 plus 10 minus 1. Our D is 8. How much is this? 10 minus 1, 9. 9 times 8. 9 times 8.
72.
So the answer is 74, correct?
Yes.
Okay, so we have 74. So we have done the first part. Okay, now second part. The sum of the first n terms, okay? The sum of the first n terms. So we are going to use Sn formula. So we know that Sn is n over 2 into 2a plus n minus 1d, correct? So we already know what is a, n, and d and everything, okay? All right, so let's substitute. So we want to find the sum of the first 10 terms. So this is S10, okay? So S10 is n will be 10,
10.
10 terms. So 10 over 2. Our A is 2
2.
plus n is 10 minus
10
1.
minus 1.
D is 8.
8.
So how much is this?
Vừa đủ lên.
It's 5.
Vừa.
5
Vừa. Vừa
into
phần 5. 7 phần
4
5. 5,
plus
4, 9 times
72,
6.
correct? How much is it? Is it 380?
Yes.
380, yeah? Okay, this is one formula, okay? So since we've already found the 10th term here, we already know the 10th term is 74. We can also try the other formula. Sn is equals to n over 2 a plus l, correct? Because we know that the last term is the 10th term if we only consider the first 10 terms, okay? So therefore S10 will be n is 10 over 2. First term is 2, last term is 74, the 10th term. So this is
76. Sama je.
correct. So we can do either formula. Okay. Okay, now third. Oh, okay, given the arithmetic sequence, B, given the arithmetic sequence, you're given 30, 23, 16, 9, 2. Okay, they ask you to find the 12th term and the sum of the first 12 terms. So let's find the 12 terms. What is A? A is 30, D is 23 minus 30 is negative 7. Yes. And they ask us to find for 12 terms. So N is 12. Okay. So therefore Tn is A plus N minus 1D. Yeah? So we're looking for T12. A is 30 plus N is 12 minus 1D is negative 7. So how much do we have here? So this is negative 47. Okay. So we have found the 12th term. Now we want to find the sum of the first 12 terms. Which formula do we want to use?
The second one.
The second
Okay,
one.
let's try the second one because it's shorter. So this will be S12. So S12 will be 12 over 2 into A is 30 plus negative 47. So how much is this?
Negative 102.
Yes, negative 102. So we leave it at that. Okay, so that's our answer. Okay, simple, huh? We just have to follow the formula given. Okay, we just for arithmetic sequence we have to identify the first term, identify the common difference. That's the important thing here. Common difference. Common difference always second term minus first term. Okay, the second term minus the term before it. Okay, and then put it into the formula and we finish with that. Okay, so we have finished with arithmetic progression. Okay, so now I'm going on to geometric sequence. Okay, in geometric sequence, example for geometric sequence, it's like this. It's given like this: AR, AR square, AR3, and so on. Okay, so the first term here is A. T1 is A. A can also be written as AR to the power of 0. Term 2 here is AR, or we can write it as AR 2 minus 1. Okay, that is AR. 2 minus 1 is 1, so it's AR. Term 3 is AR3, okay, which is AR 3 minus, sorry, term,
AR square.
yeah, AR2, AR2, which is 3 minus 1. Okay, from here, term N will be
AR N minus
3,
1.
2 is 2 minus 1, 3 is 3 minus 1. So N will be AR
N minus 1.
N minus
N
1.
minus.
Okay, correct. So this ARN minus 1, where A is the first term. A is the first term. R is the
Common
R
ratio.
is the common
Combination.
we say common ratio. Okay, common ratio, and N is the number of terms. Okay, let's look at what's given up here. Okay, the geometric sequence, the first one, 3, 9, 27, 81. What is the common ratio here? Okay, so R is equals to 9 over 3. Okay, which is term 2 divided by term 1, and this is 3. Or we can take term 3 divided by term 2, which is 27 over 9 is 3. Or we can take term 4 divided by term 3 is 81 over 27 is 3. So R is known as the common ratio because we're dividing it. Okay. Sequence number 2. What is the common ratio?
-2.
How did you get that? 10 divided by -5. So it's -2. Okay. or negative 20 divided by 10. So it is negative 2. Okay, good. Okay. Sequence number 3. What is the ratio? What is R? Term 2 is 3 over 2. Divide by 1 over 4 is also the same as multiply by 4 over 1. Is this correct? Or it is 9 divided by 3 over 2. 9 divided by 3 over 2 is also equals to 9 times 2 over 3, 6. 3 over 2 divided by
No,
1 over 4. Oh, sorry, this is 6, huh? Okay. Okay, so we know that the common ratio here is 6. R is equals to 6, huh? Okay, so all these are geometric sequences. Okay, so we already know how to get the nth term for a geometric progression. So now we're going to look at the sum of the first n terms, which is Sn. Okay, so we know for Sn for this sequence here, Sn for this sequence is A plus AR plus AR squared plus AR cubed and so on. Okay, so what is the last term here? AR n minus 1. So this is our first equation. Okay, second equation. Okay, we want to multiply it by R. So we get AR plus AR squared plus AR cubed, AR to the power of 4 until what do we get here when we multiply it by R?
ARN minus 2.
This is ARN times AR to the power of negative 1 times another AR to the power of 1. So negative 1 plus 1 becomes, so this is ARN, correct?
Oh, yes. Oh, yes.
Is that correct?
Yes.
ARN minus 1 is what? AR to the
And
power of n times r to the power of negative 1, right? So when you times another r to the power of 1, this 2 becomes 0. It
0.
becomes 0. So r
Negative
to the
1
power of 0 is
equals
1. So we have ARN. Okay? Okay. So this is our equation 2. Okay? So now we want to add equation, sorry, we want to minus equation 1 minus equation 2. And we have here Sn minus Rsn. So what happens when you minus Sn equation 1 minus equation 2? So these two goes off, right? This and this minus off, this and this minus off, this and this minuses off, right? So what is left? So we have left here
A
A
plus
minus ARN. Okay? So when we cancel everything, we only have this one, A, and we have this left. Okay, everything else is minus off already. Okay, so we have this. Okay, from here, Sn is equals to 1 minus R is equals to factorize it up, 1 minus Rn. Therefore, Sn is 1 minus R to the power of n over 1 minus R. Okay, this formula is only true for modulus R less than 1, which means R is greater than negative 1 but less than 1. Okay, so this formula is only true when R is in that situation. Okay, if not, we use this formula. Sn is equals to,
yeah, there was A.
yeah, I forgot the A. Thank you. Okay, so as n is equals to a Rn minus 1 over R minus 1. This formula we use when modulus R is greater than 1. That means R is greater than 1 or R is less than negative 1. Okay, so if you have a number line like this, 0, 1, negative 1, when R is within here, you use the first formula, okay? When R is anywhere outside here, this side here, we don't care whether it's negative or positive, then we use the second formula, okay? Can? Okay, so that is the formula for Tn and Sn for geometric progression, okay? Let's look at an example. Okay, this is our example for geometric progression. Okay, so given the following geometric sequence 5, 15, 45, 135. So we have 5, 15, 45, 135, and so on. Find the 8th term and the 10th term. So we want to find T8 and we want to find T10. Okay, let's first see what is A. A here is 5. Our R is, what's our R?
3.
3.
Yes, 15 divided by 5 or 45 divided by 15 and so on. So R is 3, okay? So from here, our formula for Tn is A R n minus 1. So T8 is equals to A is 5, R, n is 8 minus 1, correct? So what do we get here? Sorry, what is our R? We didn't substitute R. R is 3, 3, 8 minus 1, correct? So what do we get here? So 5 times 3 to the power of 7. 5 times 3 to the power of 7 is 10,935. Okay, this is our answer for T8. T10 will be 5, 3 times to the power of 10 minus 1. Okay, so using your calculators, you get 98,415. Okay, this is for part A. Now part B. Okay, the sum of the first 8 terms. The sum of the first 8 terms. Okay, we already know 8, but we are going to use the formula. Okay, so we are going to use the formula as n is A. Which formula do we use? The first formula or the second formula?
Second one.
Why the second one?
R is
R
greater
is
than 1.
greater than 1.
Yes, good. Okay, so this is the formula that we're going to use. So we're going to search for S8. Our A is 5. R is 3 to the power of 8 minus 1 over 3 minus 1. Okay, so if you calculate this, you get 16,400. Done. Okay, can? Okay, I only have time to do one example for you, but I have given you many examples in the Google Classroom, okay? Which after this lecture, you can continue looking through the examples. So I'm going to go through one last topic, which is, okay, before I go through this, okay, our last topic, infinite geometric progression, okay? Infinite geometric progression. Okay, so say we have our series is like this. This is a series, so I'm going to put an addition sign here. A plus AR, AR2, until we reach ARN minus 1. Okay, so we know that Sn is equals to A 1 minus R the power of n over 1 minus R if modulus R is less than 1. We know this. Okay, so when R, okay, when R is between -1 and 1, okay, what happens as n gets larger? What happens to Rn when n gets larger? When R is in this range, what happens to this value Rn? What happens to Rn when n gets larger and larger? Does Rn get larger or does it get smaller?
Larger.
Why larger?
Okay.
Okay, if R is in between this, if R is less than 1 and greater than -1, what kind of a number is R? R is less than 1, that means it's a rational fraction, right? Any number less than 1. Okay, that means it's like 1 over 2, 1 over 4, all these are less than 1, right? If it's more than 1, it's outside of this range already, okay? So if I take 1 over 2, okay, to the power of n, if n gets very big, what is 1 over 2 to the power of 2? 1 over 4. What is 1 over 2 to the power of 8? 1 over, okay, to the power of 4. 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, 1 over 16, right? So 1 over 2 to the power of 6, 2 times 2, 4, 4 times 2, 8, 8 times 2, 16,
34.
16 times 2, 32, 64, correct? Is the number
Yeah.
getting bigger or smaller?
Smaller.
Smaller, right? So as
Yes.
the power here gets bigger, this value gets smaller because R is in between this and this. R is actually a fractional number, okay? So when as n gets larger, only in this case, as n gets larger, Rn gets smaller and smaller. So what happens to Rn when n approaches infinity, a very big number? What happens to Rn? It approaches what number?
0.
Yes, good. Okay. This means that as n approaches infinity, Rn approaches 0. Okay. Therefore, our sum becomes, if our sum will approach a 1 minus 0 over 1 minus r, which is a over 1 minus r. Okay, that means as the number of terms become very large, like an infinite geometric progression. Infinite means there is no limit. The progression is going on and on and on. So when the progression goes on and on and on, the number of terms becomes larger and larger and larger. That means n becomes bigger and bigger and bigger. When n becomes larger and larger, Rn becomes smaller and smaller and smaller until it becomes almost 0. So in this case, for an infinite geometric progression, when you want to find the Sn, we use this formula. Sn is equals to A over 1 minus R, okay? Where modulus R is less than 1. Okay, if it's more than R, then it's difficult for us to find the sum. Okay, because Rn will approach infinity and we cannot find the sum. So whenever R is in this range, this is the formula that we are going to use to find the Sn. Can you understand this? Can? It's just the same thing as what we did earlier, okay? It's just that earlier, if there's a limit, like you want to find the sum of 8 terms, 10 terms, we straight away use the formula Sn is A times 1 minus Rn over 1 minus R. But now, if the series is infinite, there is no limit. okay, then you have to use a different formula, which is Sn is equals to A over 1 minus R. Okay, why we have to use this formula? Because the Rn becomes 0, Sn becomes larger and larger. Okay, that is the only thing you have to know for this, for infinite geometric progression. Okay, let's look at an example. Okay, here the examples are a little bit more tricky. Yeah. Okay, example 3. Okay, we're looking at the nth term of a geometric progression is given is that. So find the sum to infinity.
Madam,
Yes?
Jacinta told me she have a internet problem.
Oh, she has, okay. It's okay then.
Okay.
Never mind. She can watch the video later. Okay, how do we do this? Okay. Okay, you want to, the is given, the nth term of a geometric progression is this. Okay, let's write it out properly. It's 81 times by negative 1 over 3 to the power of n. Okay, this is the nth term. That means this is Tn. Okay, the nth term of a geometric progression is given as this. So this is Tn. This is the formula for this series. Okay, so they ask you to find the sum to infinity. Okay, so you want to use what formula to find the sum to infinity? Sn is
Sn
equal
equals
to
to A over 1 minus R.
1 minus R. Okay, so what do you need to know from here? You need to know A and you need to know R. Okay, from here, can we find our A?
Yes.
How? T,
Tn equals to
N is what? For to find A, what should we write here? T what? Which
T1.
term is A?
T1.
81.
A is which term? I mean, term number
Oh,
what?
oh, the first
Term
term.
number 1.
Term
T1.
1, right? The first term, right? So we write
Yes.
it T1. So we want to find the first term. So the first term means N is how much? First term. N is
1.
1. Yeah. So how much is this? 81 times negative 1 over 3 to the power of 1 is, cancel this, you get 27. So you get negative 27. So which means A is equals to negative 27. Don't look at the formula and get scared, okay? You just have to know first term is N is 1. Second term is N is 2. Eighth term, N is 8. Okay? So we've already found the first term. Now we need to find R. What do we need to find now? In order to find R, what should we find?
Second
The
term.
second
Yes,
term.
second term, good. Second term. So how do you find second term? 81 negative 1 over 3, n is second term. Term 2, n will be
2.
2. Okay, so how much is this? 81 times negative 1 over 3, negative and negative is positive 1 over 9. So we have 9. So we have term 2 is 9, term 1 is negative 27. So what is our R? What is our R? R is equals to term 2 over term 1. We need to find the ratio because this is a geometric progression. So term 2 over term 1. Term 2 is 9 divided by negative 27. So we have negative 1 over 3. So we know our A and we know our R. Let's find the sum to infinity. So as infinity is equals to A is negative 27 over 1 minus negative 1 over 3. So we have, what is this? Negative 27 over minus plus. 1 is 3 over 3. 3 over 3 plus 1 over 3 is 4 over 3. So this is negative 27 times by, correct? So this is negative 21 over 4. This is our answer. Can do? Okay, so the keywords that you must look for is geometric progression and sum to infinity. Okay, when you see sum to infinity, you know you must use this formula. Okay, okay, let's look at one more example. Then we finished. Okay, this one. Write the recurring decimal. Okay, there's a dash up here. Okay, there's a dash up here. So you remember this? What does the dash mean? What does the dash above 5 mean?
Number 5.
That means what?
Number 5 repeats.
Yes, number 5 repeats. That means this number is actually 0.45555 and so on. Okay. Okay. So write the recurring decimal 0.45 as the sum of a geometric progression. So how do we do that? Okay. So we know that 0.45 is equals to 0.4 plus 0.05 plus 0.005 plus 0.0005 and so on, correct? Because it's 5, it's here 5. This is over 100, over 1,000, over 10,000 and so on. So this is also equals to 0.4 plus 5 over 100 plus 5 over 1,000 plus 5 over 10,000 and so on. Is this a geometric progression? This part of it. Is this a geometric progression?
Yes.
Yes. What is the R here?
Then wait. 10.
R is term 3 over term 2. This is an example. 5 over 1,000 divided by 5 over 100. This is 5 over 1,000 times 100 over 5. So we have 1, 2, 1, 2. So we have 1 over 10. R is 1 over 10. If you do term 3 over 2, you'll get the same thing. Term 4 over term 3, also same thing. Okay, so this part is in the geometric progression. Okay, so because we have a common ratio, so we have answered question A. Okay, now question B. Okay, use your answer to part A to show that 0.45 can be written as. Okay, we want to show that 0.45 can be written as 41 over 90. Okay, so how do we do that first? Okay, so actually we want to show that this sum, okay, the sum of this series is 41 over 90. Okay, okay, let's add first this series. We have this series first. Okay, we take this part first. 5 over 100, 5 over 1,000, 5 over 10,000, okay, and so on. Let's add this series. How do we add this series? What is the sum of this series? How do you find the Sn? So which formula do we use?
The
First ask yourself,
first.
is this finite or infinite?
Infinite.
Yes, infinite. So this is infinite. Infinite means use which formula?
The sum to infinity.
A over
A over
1 minus
1 minus R. Okay, we are going to use this formula. So what is our A here? A
5
is 5
over
over 100 over 1 minus R. R we already saw is 1 over 10. 1 over 10. So this is equals to 5 over 100. 1 minus 1 over 10 is actually 10 over 10 minus 1 over 10, which is 9 over 10. Okay, so 5 over 500 divided by 9 over 10 is times 10 over 9. Okay, so we get 5 over 90. So this part, the total is 5 over 90. So for the whole series, we have 0.45. We have 0.4 plus, we have 0.05, the whole thing. So this is 0.4 plus, this one, the total is 5 over 90. 0.4 is actually 4 over 10 plus 5 over 90. Okay, 4 over 10 plus 5 over 90. So this is how much is this? 90 divided by 10, 9 times 4 is 36 plus 5 is equal to 41 over 90. Okay, so we have shown